So far, everything was straightforward. Next example, we're going to add a wrinkle to this rule. And in this example, we need to evaluate something looks like this, the integral of t squared e to the t dt. Before I move on, I want to just remind you that how we work with differentials. For instance, if you have u as a function of t, then du dt will be u prime, right? So du is u prime dt, and if v, the function v is a function of t, then dv dt equals v prime, and then dv is v prime dt. Okay, just a quick reminder. All right, so now we're going to let u equal something and dv equal something else, and after making the choice, we'll find out, we'll evaluate du and v. All right, your thought, we have the product of t squared and e to the t dt. What will be the choice of u and dv? There are two possibilities, right? I'll take a vote here. All right? I want you to participate, no absent. Okay. The choice A is choose u equal t squared and dv equals e to the t dt. How many think this will be the right choice? Raise your hand. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Thank you. The other choice is u equal e to the t and dv equal t squared dt. How many people think, and this is choice B, how many people think this is the right choice? U equal e to the t and dv equal t squared dt. Okay, you two, you didn't vote for the first time. I said no absentee. So if you didn't vote for A, you need to vote for B. What is this? You are changing your mind after the election? What's going on here? Well, the majority this time was right, actually. The first choice was correct. But you'll see that we don't get immediate relief by choosing. So we'll choose u equal t squared, and therefore what we are left with, dv equals e to the t dt. Now, this is a good choice because v is e to the t. This is an integral that we love. Okay? But the du now will be 2t dt. Okay, that's why I gave you this note. So, let's see what happened at this time. So we're going to apply the rule. This time I'm not writing the rule. And the integral of u dv t squared e to the t dt equals the product u times v. Well, it will be t squared times e to the t minus the integral of v du, the integral of e to the t times 2t dt, right? We'll call this equation star because we are still not out of the woods here, because we have this integral, I denote it in the curly bracket. So I need to work on this integral, okay? So I'm going to look at this integral. So we need to evaluate I'm going to rewrite this. It will be 2 times the integral of t e to the t dt. Okay, so this is the integral that are marked with the curly brackets. So let's do it again. Let's write 2 times the integral of t e to the t dt. I could have left the 2 and multiplied after, but there is always a chance that we'll forget to do so. Okay, so before we move on, actually this was a little bit premature because now we need to choose another set of u and v. Okay, so before we can solve it, let's make another choice. Are we going to repeat the choice that we made before? We're going to let dv still be e to the t dt? To answer my own question, yes, it was comfortable. Plus, if I choose u as t, then du will be simply the t, which is a desirable result. So we'll choose u equals t and dv e to the t dt, and therefore du equals dt and v equals e to the t. And now we're going to say that 2 times the integral of t e to the t dt, and this is the one that we marked with the curly bracket, will be u times v. Well, that will be t e to the t, but we have 2 of those, right? We need to multiply by 2. Minus 2 times the integral of v du, e to the t dt. Now this integral we can handle nicely. So we end up having 2t e to the t minus the integral of e to the t dt is e to the t, so minus 2 e to the t. Okay, so we plug the result, plug this result in the equation that I mark with the star. So go back and substitute this with that, and let's see, we end up having the integral that we started with, t squared e to the t dt. We had t squared times e to the t, and then minus this result. Okay? So we have minus 2t e to the t minus 2 e to the t, and then we have plus c, and we see that we have a common factor e to the t, so we'll factor it out, and we have 2t squared minus 2t plus 2 after clearing the parentheses times e to the t plus c. Once again, I want to check it. And we just take the derivative d dt of this thing. And we apply the chain rule. So it will, I'm sorry, the product rule. We have a product here. So 2t minus 2 times e to the t plus t squared minus 2t plus 2 times the derivative of e to the t, which is e to the t, plus 0. And now factor out e to the t and get 2t minus 2 plus t squared minus 2t plus 2 times e to the t, and 2t minus 2t reduced, and negative 2 and positive 2 are reduced, and we end up having t squared e to the t as advertised. So we have the right result. So the wrinkle was we had to do integration by part twice. Okay, so note the presence of t squared as u, or the choice of t squared of u, leads to integrating by parts twice. So instead of presence, let's write choice. Okay. So what would have happened if we had t cube? We have to do it 3 times.